handling is the backplane capacity. Okay, so I'm talking about a backbone now. This is a backbone structure, skeletal structure, that's a backbone. Now let's say the leaf switches are all sending traffic and there are two distributions in this situation, two distribution switches, DST1 and DST2. Now, in a situation like when your network manager tells you we got to add more bandwidth. What do you mean by adding more bandwidth? He's not talking about adding more bandwidth on internet. Did he say internet is utilization is high, you got to add more bandwidth? No. We are talking about expansion at the LAN level, right? So when we are talking layer 2 switching, never think about internet, because it's not a layer 2 technology. What do you have to think about internet? Our thought should be aligned towards the local area network or the switching environment. Yes, we need to think internet, think bigger. when we want to see how the LAN will compensate in terms of whether you have a LAN nice switching environment which will make the internet work fine. What do you mean by? Means if you have a problem at your own LAN and you expect to troubleshoot internet, okay, the problem is not internet, the LAN is creating trouble. If you have a timeout because the switch is having some issue and people are complaining, you don't have to go troubleshoot internet because it's your local issue, local area network issue. You got to understand that way. Very important, our entry points are very important. Do you guys agree that the gateway is a very important point? Yeah. If the gateway itself is not available or having issues, forget. Further hops or internet and all is a later story. No need to trouble. Okay, very important. Not for CCNA, but it's a very important thing to for support people to understand. Is it's part of the CCADA Design Associate certification. We talk about something called top-down approach and bottom-up approach. Okay, so the bottom-up approach and the top-down approach. Actually, troubleshooting always should start from bottom-up. Physical layer. Bottom-up. Remember, you network support, forget about top-down. You need to know there is also another approach top-down. But yes, bottom-up is the best way. But what if the application has an issue? What approach will you use?
It's up.
Top-down. Okay, you got to understand what scenarios will fit where. What scenarios you will fit where. Okay. This is not network approach only. This is also approach for every solution, every problem. In your life also we can use this approach. I've been using sometimes some bottom up, top down. You'll see where exactly could be the problem. Then you are using the approach. Exactly, you are using this approach. You'll see whether there's a problem with some water is not flowing easy. Then you'll think where could be the congestion. Where could be the congestion? Whether the congestion is on the top. It cannot be bottom because you are in the second floor and the water is not coming to you properly. It's a pressure which is getting created from the top. It should be the troubleshooting from a top-down approach. So absolutely, it's you can see that, right? It so fits into our life also. So that way we are not so much disconnected in the network class. Network is also part of our life. So we'll take lots of examples possible because routing is much more interesting. I'll be on the road. When I start about routing, I'll be on the road. I'll be on the road. I'm a driver and I'm sitting in the car and I have troubles going to the destination, reaching, have a congestion. So routing is all about that. Metrics, what metrics and all. Routing is much more interesting, more logical because that's a logical layer. That's a logical layer of IP addressing, right? There's a logical layer. So coming back to the capacity, let's not deviate much, right? Now, how do we add more bandwidth here on a LAN is as simple as that, add more ports. Uplinks, it's not ports. By adding just more ports here on the switch will not help until they are configured and they are operational. Point number one. We need to ensure that just somebody said, oh okay, we'll add more links, okay, bring more 2 links, we connect here. Until the port is operational, it's been configured properly, it is not serving the purpose. Okay, we got to ensure that the traffic is moving through this port. Okay, now let me add one port here. Okay, one more. Let me add one more port here. How many ports here? Now, whenever you see a topology, a circle like this, whenever you see in any topology, network design, any architecture, a circle like this between a line with the links, 2 or 3 or more links, please understand there is a technology called ether channel implemented. It's called port aggregation technology or link aggregation technology. In a IEEE fashion, or the not proprietary, they call it as link aggregation. Cisco have technology called port aggregation, Cisco proprietary. But they also support LACP, link aggregation control protocol. There are 2 protocols for either channel now to understand. Okay, one is the LACP, which is not proprietary, nobody owns it, nobody has the name tagged to it, anybody can use it. Link aggregation control protocol. Another is what? PAGP. LACP. Okay, I'll put the content for that on so that I don't have to so much worry, right? Okay, it will be there. Okay, now let me clear the board for you. What does it say in the channel? For achieving why I put port upon link is I'm covering both. It's same word. Port and link aggregation has no different meaning. That's why I put an icon saying it's same. Means I'm trying to say